In 3.8, we are going to be graphing absolute value functions. Now, with an absolute value function, it's going to be in the format of y equals a times the absolute value of x minus h plus k. For all of our graphs for an absolute value, they are going to look like a V graph. They will look something like this or downwards like this. Now, in order to actually graph these, our step one is the most important. We have to find the vertex. So what we're doing is we are finding the middle x value. In order to do that, we take what is inside of the absolute value and we set it equal to 0 and then solve it if we need to. Now, once we have that x value, then we will make a table of 5 values in total. 2 numbers will be smaller than the x that we found, and 2 will be larger. Step 3 is we will plot those points, and then step 4 is finding the domain and the range. So in example 1, we're going to graph the absolute value function and find the domain and range. So our function is f of x equals the absolute value of x. So over here off to the side, sorry, my board moved, let me redo that. So over here off to the side, here is x and y. What we have to do is we have to find the original x value. So we are going to take what is inside of the absolute value, which is x, and we are going to set it equal to 0. Now this one is already solved, so it means the x of our vertex is 0, and you put it in the middle of your table. Then we will count up to 1 and 2, and then down to -1 and -2. Once we have the x values, we will then take each x value and plug it back into our original function. Since it's just the absolute value of x, if we plug 2 into x, it'll be the absolute value of 2. The absolute value of 2 is 2. If we plug 1 into x, the absolute value of 1 is 1. If you plug in 0, absolute value of 0 is 0. If you plug in -1, absolute value of -1 is +1. And if you plug in -2, absolute value of -2 is +2. Now, if you guys notice, if we look at our y values are symmetric. So if you look at this first y value and the last, they are both 2. If you look at the second and the fourth, they are both 1. And then this middle right here, that 0, 0, that right there is our vertex. Okay, so everything will become symmetric based off of where that vertex is. So what we are going to do is we are going to plot those 5 points. So we have a point at 2, 2, 1, 1, 0, 0, -1, 1, and -2, 2. When you plot your points should make a V. If it makes a V, then odds are you did it correct. So once you have that, we are then going to graph. Let me get my straight edge. And we are going to connect our points so it looks like a V graph. And do not forget arrows on both sides. Now, once we graph it, then from there, move this down, we have to find our domain and the range. Now, for your domain, remember domain is all of the x values that we have. We could use any single x value and get an answer. So because our graph is constantly going to the left and to the right, it means that our domain is going to be all real numbers. Now for your range has a restriction. Because your graph is opening up, it means we are only using the positive y values. So whenever the graph is opening up, we say the range has to be y is greater than or equal to, and it's always the y of your vertex. Our vertex is 0, 0. The y value is 0, so it ends up being y is greater than or equal to 0. For B, we have negative absolute value of x. So off to my side here again, I'm just going to go ahead and have x and y. To find the original x value, we take what is inside, which is x, and set it equal to 0. It's already solved, which means the x of our vertex is 0. That will go in the middle. We're going to count up to 1 and 2, down to -1 and -2. So now we're going to go ahead and plug in our values. So if we plug 2 into x, we have negative absolute value of 2. Now that negative in front is really a -1. Absolute value of 2 is 2, and you multiply the 2 together. So -1 times 2 is -2. Now remember, because the y values are symmetric, if 2 is -2, it means -2 will also be -2 because they have to be the same. If we plug 1 into x, we'll have negative absolute value of 1. So that is the same thing as saying -1 times +1, which gives us a y value of -1, which means -1 will also have a y value of -1. Then we're going to plug in 0. So negative absolute value of 0 is the same thing as saying -1 times 0, which is just 0. So remember, this middle right here, that is our vertex. So our vertex point is at 0, 0. Now we're going to go ahead and plot all these. So we have points at 2, -2, 1, -1, 0, 0, -1, -1, and -2, -2. Now when we plot this, we can see that our points did make a V graph. So odds are, hopefully we did it correct. Now we just have to go ahead and connect them. So here is one, here is the other line with arrows on both sides. Now that we graphed it, we do have to identify the domain and the range. Remember, domain, we can use any x value that we technically want. So the domain is all real numbers. For the range, because our graph is opening downwards, it means we are using all of these smaller y values. So our y values have to be less than or equal to the y of our vertex. Our vertex is 0, 0. The y value is 0. With the next one, we have the absolute value of x plus 2. So I'm going to go ahead and create it. Here's the table, x comma y. To find the original x value, we take what is inside, which is x plus 2, and set equal to 0. This one is not solved, so we do have to solve it. So to get x by itself, we subtract the 2. So our original x value has to be -2, which means -2 goes in the middle. We'll count up to -1 and 0, down to -3 and -4. Now we're going to plug everything in. So if we plug 0 into x, it'll be the absolute value of 0 plus 2, which is just the absolute value of 2. So the y value is 2, which means for -4, the y value will also be 2. If we plug in -1, absolute value of -1 plus 2 gives us the absolute value of 1, which is +1, which means for -3, the y value is also +1. If we plug in -2, absolute value of -2 plus 2 gives us the absolute value of 0, so that y value is 0. Just like on all the others, this middle ordered pair, that is our vertex. Now we're going to go ahead and plot those points, so we're all going to go ahead and do that here real quick. Once we plot our 5 points, we can see that it did make a V. So with that, we're like, okay, more than likely we did it correct. So now we're going to go ahead and connect the points together with some straight lines. And we need to make sure we have an arrow on both sides. Now that it is graphed, we can identify the domain and the range. Again, domain, we should always get correct. That's going to be all real numbers. For the range, our graph is opening up, so we are using all the positive y values. So it has to be y is greater than or equal to the y of our vertex. Our vertex is -2, 0. The y value is 0. With D, we're going to graph the absolute value of x and then -3. So here's our table, x and y. Remember, to find the x value, you only take what is inside of the absolute value, which is x, and we set it equal to 0. The x is solved, so 0 goes in the middle. We'll count up to 1 and 2, down to -1 and -2. Now we're just going to go ahead and plug everything in. So plugging 2 into x, absolute value of 2 minus 3. The absolute value of 2 is 2. 2 minus 3 gives us -1, which means for the x value of -2, y will also be -1. If we plug 1 into x, absolute value of 1 minus 3. Absolute value of 1 is 1. 1 minus 3 is -2, which means for -1, the y value is also -2. If we plug in 0, absolute value of 0 minus 3 is just 0 minus 3. So that y value is -3. So it means that our vertex is going to be the ordered pair 0, -3, and go ahead and plot those points. Once we plotted all 5 points, we can see that it did make a V-graph. So because it made that V-graph, now we are going to go ahead and connect them with a straight line with arrows on both sides. This is what our graph is going to look like. And then we will have our domain and the range. So for our domain, just like on all the others, it is going to be all real numbers. For the range, because the graph is opening up, we're using all those positive y values. It has to be y is greater than or equal to the y of our vertex is at 0, -3, so the y value is -3. For this next one, we are not going to plug it into a graphing calculator. What we are going to do is we are actually going to solve this down by hand, because you have to know how to do that by hand. So our equation is -2, absolute value of 3x minus 6 plus 5. So here we are off to the side. Here's my table, x and y. First thing we have to do is we have to find that x. So we take what is inside of the absolute value, 3x minus 6, and set it equal to 0. Have to solve it down to get x by itself. So we would have 3x equals positive 6. So when we divide by 3, the x value is 2. So 2 has to go in the middle. Then we'll go to 3 and 4, down to 1 and 0. So what we need to do is we are going to take 4 and we are going to plug it into x. So we're going to have -2 absolute value of 3 times 4 minus 6, and then we add 5. When you solve this, you always have to do what is on the inside of the absolute value first. So 3 times 4 is 12. So we really have 12 minus 6. So that will give us -2 times the absolute value of 6 plus 5. Now the absolute value of 6 is just 6, which means this is really -2 times 6, and then plus 5. -2 times 6 is -12. When we add the 5, we will get a y value of -7, which means for 0, it will also be -7. Now we are going to take 3 and we're going to plug it into x. So -2 absolute value of 3 times 3 minus 6, and then plus 5. Again, do what's inside of the absolute value first. 3 times 3, we know is 9. So that means we're going to have -2 absolute value. 9 minus 6 is 3, and then plus 5. Now, absolute value of 3 is just 3. So it means we have -2 times 3 plus 5. -2 times 3 is -6. Add the 5, and we get a y value of -1, which means 1 will also be -1. Now we have to do that one more time with 2. We're going to take 2 and plug it into x. So it'll be -2 absolute value of 3 times 2 minus 6, and then plus 5. 3 times 2 is really 6, okay? So we have the -2 on the outside. Inside of the absolute value, 6 minus 6 is 0, and then plus 5. Absolute value of 0 is 0. So this is -2 times 0 plus 5. -2 times 0 is 0. 0 plus 5 gives us a y value of 5. So that means that 2 comma 5, that right there is going to be our vertex. So we're gonna go ahead and plot those 5 points, so everybody take a second and do that. Now, once we plot those 5 points, again, it should make a V, which it does. So once we have those 5 points, we are going to go ahead and connect them with a straight line. So here is one line. Here's the other line. We need to have arrows on both sides. So that's what our graph is going to look like. And then our domain and the range. Domain, we already know that has to be all real numbers. Since the graph is going downwards, the arrows are going down. It's all the smaller y values. So for the range, it has to be y is less than or equal to. Our vertex is 2, 5. You take the y value, which is positive 5. For the last one, this one you guys are going to try on your own. So pause this, get that done, and then go ahead and replay it again so you guys know if you guys are doing it correctly or not. And this right here will be that final answer.